This is a demo as part of my sort of exploration with AI and proving to teachers that it can greatly benefit your, as part of your process for test creation, um, and how that can help you sort of ensure academic integrity because you can create a bunch of different variations of tests. So I'm going to ask ChatGPT right now. I'm going to ask O1 to do this. O1 is their most advanced model, especially for mathematics. I think it scored 91st percentile on the AMCs. Correct me if I'm wrong. It just much better at math and logical reasoning. In fact, I'm pretty sure when it says thinking, it shows like a thinking bubble here. You can click on it and you can see how it's, sort of, you can see its process for reasoning and, how it actually thinks, because it has similar process of thinking as a human would. So that's really quite interesting and scary to think about. And that's ChatGPT right here. Create a 150 problem exam on calculus 1. We can say multiple choice exam on calculus 1. And make sure to output in latex. The name of the class is calculus 1, and the instructor is, I'm going to put my name, Vay Krishna. Let's see what it does right here. Thinking, crafting a calculus exam. See this. This is its reasoning right here. And while it outputs, let's see this here. I'm assembling a 150 question multiple choice exam on calculus 1 covering topics like limits, derivatives, integrals, FTC, in latex, concise, detailed latex code snippet, limits, derivatives, integrals, into sections, pre-calc review, limits, derivatives, applications, related rates, implicit differentiation, integrals, techniques of integration, integral applications. Again, typical in Calc 1. Concise, diverse, multiple choice, focusing on Calc 1 topics, each question unique and concise. Okay, let's see. It's still generating, by the way, here. It's quite interesting. It's thinking like a human would. And look at it, it's still going. And of course, we're going to take a look at this here to see if the problems are actually any good. I anticipate that they will be, because ChatGPT didn't really have a good reputation for solving math problems, but creating problems. I mean now with O1 solving, 91st percentile in the AMC. It's pretty good. So it's still going. Okay, now we're done. So right now I have a latex IDE going here. I'm just gonna paste the code that ChatGPT outputted. I'm gonna compile it, and okay, gave some extra page here. What's this thing here? Let's recompile, and look at that. So we got the final exam here. Consists of 150 multiple choice questions covering material calculus 1. Select the best answer for each question. No partial credit will be given. Good luck. I didn't ask it to say this though, but I guess that's typical, right? Because of how ChatGPT learns. It learns from a large set of data from the internet. It probably looked at past calculus exams, and it probably said a lot of stuff like this, like select the best answer for each question, no partial credit. Also, it assumed it was a final exam. I don't think I told it was a final exam. It just said on calculus 1. I didn't say it was a final exam. It just says final exam. So maybe it's because it's fed, it looked through a lot of past final calc 1 exams, and because 150 multiple choice questions, I said just on Calc 1, assumed entirety of Calc 1, so because of that logic, they need a final exam. That's what I would do if someone asked me to do that. If it's on Calculus 1, I'd assume they already know entirety of Calculus 1, so it's a final exam. So let's see here, this is a limit, right? Direct substitution, this right here, 3 times 2 minus 4, should be 2, okay. It's kind of weird. I've not seen multiple choice, like again, this limit here specifically, and again, I'm going to download this so we can actually zoom in and stuff. Again, isn't that crazy? Like, again, what I'm using is Overleaf. You just click download, and here, you got your entire exam. Okay, well, also, one more thing that's interesting here. It says problem 140. Okay, it didn't give me 150. Now, this may just be due to the token limit here. 150 multiple choice questions is a lot, but 140, pretty good. Anyway, let's go back to here. This is kind of interesting. First question, they actually go over the arithmetic process, right? Like, again, this is direct substitution limit here. This would just be 3 times 2 minus 4, so that would be 2, and of course that's A. Okay, this maybe. I would say it's a pretty easy question. I think that, direct substitution, it's pretty much implied here. This is a polynomial. You're just plugging into, this right here is a special trig limit. Okay, good. This right here, okay, interesting, right? You're just plugging in, you're directly substituting. Okay, that's a good question. This right here, also good. This is just indicates horizontal asymptote, so it would be 2. Again, good types of questions here. Like, what does this represent? Well, it represents the equation for the horizontal asymptote, because this is an end behavior, right? Good question. F of A is not defined. Okay, continuity questions. This is important. Continuity is a crucial part of when you're studying limits. This right here, a trig limit, good. This is also a special limit. Again, you learn L'Hopital's rule in Calculus 1. So if you don't know special limits, you can just do L'Hopital's rule. But remember, it has to be an indeterminate form in order for L'Hopital's rule to apply. So you got to be careful here. This is also, special trig limit here as well. Sine x over x. Not bad limit questions overall. Let's see, sine of x over x is continuous. More continuity, that's good. Left-handed and right-hand limits, very good as well. Specific limit, continuity. I love these generalized continuity questions are always very good, right? Like if it's continuous at a point, what must occur? So it's really nice that they're asking these fundamental questions as well. Again, I think that's much better than asking a question like this. I mean, to be fair, it's the first question, so like free point, just direct substitution. So I mean, I guess so. If that was like the 79th question, you'd be like, why? I mean, it's kind of out of the ordinary, right? But again, it said it divided it by sections, so that's gonna be interesting to see here. Right now, it's all limits. Okay, continuity, yada yada yada. Okay, now it says specifically use L'Hopital's rule. This, again, same problem as, I think, this, right? Problem 8 and, oops, where is it? Where the heck is it? Why can't I find that problem? It's like using L'Hopital's rule, right? I don't even remember. Yeah, here, right? Same problem as number 8. Why would you do that? It's like, because the person could just use L'Hopital's rule for that problem as well, right? Like, now, assuming that your work on the final exam, this is not typical at all for college final exams. Like, they grade you based off of the work as well with the multiple choice. Like, It's usually just Scantron and that's it. Um, so if you use L'Hopital's rule for problem number 8 and you didn't recognize the special limit, then you know what's the point of this problem here? Um, Again, I would say a good L'Hopital's question, where it specifically says L'Hopital's, is when someone thinks it's an indeterminate form but it's actually not, and then they apply L'Hopital's. It could be a trick question, like L'Hopital's rule doesn't even apply. That's a good question. Squeeze theorem, that's also pretty good. Yeah, squeeze theorem. More limits. Okay, different. This is now we're in derivatives now. It didn't say new section. This is a derivative question, because here it's like this. There's a sharp turn, so it's not differentiable at that point. And if it's not differentiable, it's still continuous, because continuity doesn't imply differentiability, but differentiability does imply continuity. Here, more limits, continuity. Okay, now we're in derivatives. Also, nice intermediate value theorem. That's often ignored after a while, because it's actually a theorem that's not really calculus based. It's an existence theorem. It's an existence theorem. Like if interval is continuous, we have this point, like there must be some point, but it's an existence theorem, right? That's often studied in pre-calculus, of course brought back into limits and continuity, and that's forgotten. So it's very nice that they included this here, because after studying limits, people often forget this. More limits than derivative. This is just a power rule question here. Trace, sine of x, cosine of x derivative. These are generic derivatives, like this question here with the x to the n, kind of a flawed question, because again, it didn't specify that n is constant, because if n was like a function that's continuous and differentiable, then the derivative could be a lot different. Like, for example, if you have f of x equals to x to the power of x, right, or x to the power of y, right, and they're not constants, right, then you cannot use power rule. So kind of a flawed question here. I would recommend, like, again, it's kind of implied, like, the best answer choices out of these would be nx to n minus 1, but the actual answer choice would just be none of the above, because, or just cannot be determined, because we don't know where n falls into. So again, nx to n minus 1 is probably the best out of those answer choices. Again, these are generic derivatives. That's good. I'd recommend doing, again, I have mixed opinions about, derivatives that are more based on algebraic skill, but at the same time, I'm talking about more with the simplification process, but at the same time, you should know how to apply the rules. And then derivative of constant. These are more fundamental questions. It's good. Fundamental questions are okay. Product rule, I like these general expressions, just sort of like a different way. Like, usually we'll see it as derivative of u times v, okay, f times g. Looking at it from a different way, I guess. Again, chain rule, like, these are all very foundational sort of questions. I often don't like these kind of specifically these types of foundational questions, because it's often just a memorizing thing. Just from your head, what is chain rule? Again, you should know them. You should 100% know them. And again, watch my Understanding Not Memorizing series, or look at my new recent articles where I go over in detail how these can be easily understood and proved. Just knowing calculus and logs and geometry and stuff like that. So, these questions, not my favorite type of foundational questions, but it's okay. They're not bad. Again, this is just some chain rule stuff. Great. Product rule. Nice parametric question. Pretty nice. Okay. Again, kind of generic derivatives here. This is awesome. Chain rule. Nice. This type of chain rule question I do like. It's good. Okay. Again, inverse trig derivative. Okay. Chain rule. Inverse trig. More derivatives. This is quite a nice equation. Like if you're taking, just go try. It's kind of like introducing you to not necessarily the concept of the antiderivative, the antiderivative. Kind of going back, like which function's derivative would result to this. So I guess it's kind of a foundational question. Okay, just kind of definition of the derivative itself. It's the slope of the tangent line. More derivative stuff, applying rules. Awesome. Chain rule. This is okay. I mean, all right. Second derivative is the derivative of. Okay. I mean, all right. Maybe a trick question for people, who do not remember what the second derivative is. I assume if you know Calc 1, you should know what the second derivative is and what it implies. Like right here, second derivative implies concavity, right? Like this would be concave up, like stuff like that. I think you should know that in Calc 1. So I think that question is a little weird, but okay. I mean, it's free points. I think that the students will be really happy. A lot of this is just foundational stuff, not necessarily trick questions. Again, my understanding of math, is much more advanced than the average Calc 1 student. But I think that a Calc 1 student would be happy with this exam in terms of difficulty. It's not too bad. It's like there's some like key generalized sort of questions that you kind of have to be careful about, but it's good. GPT, not bad. Let's continue here. Okay, more just foundational stuff here. Okay. Critical point. Again, another thing with critical points, I would say a good trick question maybe to ask is, remember, a critical point has to fall within the function's domain. Now this is very crucial because sometimes, again, to find the critical point, it's not only to set the derivative equals 0. For example, if you have some sort of rational function, you also have to set that denominator equals 0, because that also is how you find a critical. That could potentially be some sort of point where it's changing from increasing to decreasing, or decreasing to increasing the function itself. So that's a pretty good trick question. Like, if the domain of f is from -3 to 5 closed interval, and we find by taking the derivative f prime of x, getting a critical value of x equals 7, or we find that's when setting the derivative equals 0, f prime of x equals 0, we get a value of x equals 7. What does that say about, is 7 a critical value? I don't know. I think that's a good question because it's kind of going back truly into your foundations. What does a critical value actually represent? What defines a critical value, etc. Mean value theorem, very important. I would not necessarily say recite the mean value theorem, more of a problem that involves it. At what point C does the instantaneous rate of change equal to the average rate of change? Something like that would be a little better. Just like the phrasing doesn't just say using the mean value theorem. It's more like you see some sort of wording and it's like, oh wait, this is just a mean value question. Because by phrasing the definition of it, you'll know oh, I have to apply this, right? Because the mean value theorem tells us when the instantaneous rate of change equals to the average rate of change. It's just pointing out ideas, but let's continue here. F prime x equals 0, x equals 0. Okay, again, like first derivative test, increasing, decreasing chart. Nice. This is kind of similar to that one question. I'm not going to go back to it. I don't want to get lost. 150 questions, 140 questions. GPT didn't fully listen to me. But it asked a question with differentiability here. Kind of the same repeat question. I don't know. Slope of the tangent line x equals 1. Again, just going back to what does the derivative represent? It represents the slope of the tangent line at a particular point. Instantaneous rate of change. So yeah, just slope of the tangent line, just know you take the derivative and plug in 1. That's their slope. Okay, foundations, pretty good. More foundations. Okay. Again, this is just like an algebra question. I mean, just like, I don't know, maybe just go more deep into it, like find the local min or local max or whatever. I don't know. Or does one exist? Maybe not just say finding f prime, but setting f prime of x equals 0, find the x values. I mean, it's just a quadratic at this point, right? It literally gives you the derivative. You're just you're just solving this quadratic equation right here. I mean, algebra. I think an algebra 1 student could do this, because it's like, even without knowing the meaning of f prime of x, it's just setting whatever this guy is equal to 0. Well, that's just a quadratic equation. I can do that. Factorizing. Don't you dare use the quadratic formula for this one. I'll be angry. Using the first derivative test. Okay. More foundation. More foundation. Okay, second derivative test. Glad they brought it up, because second derivative test is something. There's a lot of misconceptions with the second derivative test. They think the second derivative test is something completely different, but second derivative test also helps you find extrema, but it also just uses the principles of concavity, because the sign of the second derivative tells you whether it's the function is concave up or concave down, and using that with the critical value, that can help you a lot, but sometimes that can be inconclusive. But very important that people know the second derivative test, because there are instances where you will have to apply the second derivative test, because sometimes you'll just be given the derivative and you won't be given like a point that belongs in the original function, and you'll have to, again, some other info, like, I don't know, like, there are instances where you will have to use the second derivative test. It's not possible for you to use the first derivative test. And sometimes there are instances where it's not possible to use the second derivative test. You have to use the first derivative test. But yeah. More foundational stuff. I mean, I think they could be a little more specific with the problems. It's a lot of foundational stuff, which is good. The harder foundational questions you should keep. But sort of just definitions, like what does it mean when the first derivative is positive, stuff like that. Like, I mean, it's kind of, you should know that at this point. I think you should kind of dig deeper a little bit. The questions are like, they're all kind of foundational, you know, like, I mean, maybe be a little more like creative with the problems, right? Like, I understand, like, I get what it's trying to do, and I really think it's nice what it's trying to do here. But again, it could be a lot better. Again, if I asked GPT-3 back in 2022 to do this, I don't think it can. So honestly, very, very good. So related rates problems, maybe give an actual related rates problem. But yeah, I mean, I think even if you didn't even know what related rates is, you could probably answer this question. Rates, derivative, time, rates involve time. Okay. Dy, dt. Okay, some parametric stuff. Okay, this is good. We're getting some kind of specific related rates from. I think, you know, like, this is, again, obviously a Pythagorean theorem type thing. Maybe just give this like, um, give this and maybe call the ladder some other side and just say what is the rate of change of the ladder. Maybe not, instead of saying differentiating, just talk about rates of change and stuff. And don't just say differentiating, because anyone can do this. You didn't even need to give this, right? This is kind of irrelevant. Just, you could have given this and just say differentiating with respect to time gives of just this thing. This ladder stuff is completely irrelevant if you're just saying this stuff. I think it should just say like, find the like find the rate of change of the ladder, sliding, or the rate of change of the what am I trying to say here, of the ladder sliding, like, down the wall with respect to time. Like, this is completely irrelevant. I think you missed an opportunity there. Optimization problems, again, kind of related, rates problems. I think that someone who doesn't know calculus maybe could figure this out, because you could do optimization without calculus in certain instances, like quadratic, right? Find the maximum for quadratic. Sometimes you'll get some relationship. A perfect example is like if you're constructing a pen, with fences and stuff, and you're given certain information, and you'll get some algebraic relationship that results in a quadratic. You can find the maximum area of, or the maximum perimeter, whatever it is, of the pen using the given amount of material, like stuff like that. Like, if you can do optimization even in algebra class. Of course, when you're dealing with degrees higher than 2, then you'll have to use a calculator to find their extrema, because you don't know derivatives yet. But optimizing, right? Like optimizing, you're trying to find the maximum or the minimum of something. It's just like English, right? You're optimizing. You're trying to take full advantage of something. Like, and that full advantage could make something like minimum as like cost effective, or maximize, and I'm using as I want to maximize the potential of the material to build my pen. I wouldn't say it's really that creative of a question. Optimize function or closed interval. Okay, this is good. Like closed interval. Like, there are special things with closed interval. I've heard it as the candidates test, right? You're like using candidates, and you plug in the endpoints and then your critical points. Very, very important to know that, especially in a closed interval, because that's often what the real world is based off of, closed intervals. We're not always in the world of real numbers, right? So, yeah. Linear approximation, linearization, very important application of derivatives. Okay. Differential. Okay. This is kind of like separation of, or what is this? Okay, it's like they're separating the variables. Okay, that's, mean value theorem. Okay, this is a good question, right? Like, the criteria for mean value theorem. That's a good question. I think criteria. Even going deeper is if you give them a question, like find the instances, find the value C where the average rate of change is equal to the instantaneous rate of change, the values depending on the case, and it could just not satisfy the criteria of the mean value theorem at all, and then it could, like, one of the answers is like none of the above or something like that, or not possible because it doesn't meet the criteria of the mean value theorem. That would be an awesome trick question. Rolle's theorem, very important. People often forget Rolle's theorem. It's a special instance of mean value theorem where the outputs of the two endpoints are equal to each other, so the slope is 0. So again, that's forgotten case of a Rolle's mean value theorem. Rolle's theorem is often forgotten. People usually only remember mean value theorem, but that's fair enough because Rolle's theorem is a specific instance, right? Special case. Greater than, less than. Again, kind of go. I think they asked this question already. I think this was a repeat. Again, there's a lot of derivative stuff on here now. Finally, they're getting into integration, which is really good. So the next 50 questions be integration, antiderivative, foundational question. This is power rule. Here again, n, they should define what n actually is, which number system is it in. Just your trig integrals. I'm gonna skip this kind of stuff. This is all like generic sort of, they're not interesting questions. These are, I would expect this Calc 1 class to be a very generic Calc 1 class. It's not interesting, the problems. Again, ChatGPT, I asked the GPT to just create a 150 problem multiple choice exam on anything, just Calc 1. I was being very generic. I did not indicate the level of difficulty. I would say the level of difficulty for this exam is pretty easy. Okay, for pretty much any Calc 1 student would be fine. They'd be happy exiting the final exam. I didn't indicate the difficulty. And again, after this, what I'm going to do is I'm going to ask it to make it really difficult. I'm going to see how it does. Okay, now keep in mind, 01, it's gotten a lot better at solving problems. Its reasoning is very interesting. Hopefully, it'll be better when I ask it to do more. Be more specific. Like, I'll give it the most difficult problems. Okay, that's maybe not more specific. I'm like, I could say, for example, I could give them all the critiques that I'm letting you guys know, like mean value theorem, give specific types of like trick questions, like critical value, right? Does this fall within the definition of critical value? Stuff like that. Let's see how it does. I'm not gonna tell ChatGPT that's just too much typing. I'm just gonna say make it more difficult. Let's see how it does. Right here. So FTC, okay. Definite integral. Okay, this is good. I would say a good answer choice here. This again very easy. Displacement, but again, I would probably say you should probably put total distance as one of the answer choices as well, because the thing that people mess up the most, and again, this is like generally speaking, right? Like total distance and displacement are completely different things, right? When you integrate, there could be negative area, right? Because integration, the definite integral represents the area under the curve. Again, so that area can be negative, right? And so that negative area, right, that won't give you total distance, right? So that's why you have to have absolute value bars. But sometimes people mix up displacement. Displacement actually accounts for that negative area. And again, part of that is understanding like how does area under the curve relate to the definite integral. And again, read my papers on that. I recently, I think I mentioned this already in this video, I created some articles on this type of stuff. I myself know a bit of LaTeX, so I use LaTeX to create them. But yeah, I created some articles on this type of stuff, like understanding how FTC and integrals relate to area under the curve. Like how does the Riemann sum, finding area under the curve using rectangles, how do we get the same value by just reversing derivative? It's cool stuff. Again, I would say a good answer choice here. Just put total distance. It's good question. Test to really test the understanding. F is continuous. Okay. More of this stuff. Okay. This is again super duper. Yeah, obviously it's a U sub problem, but because you're doing separation of variables and stuff, it's not interesting. Um, Integration by parts. I'll try out Voodoo. Average value of a function. Again, it's like essentially mean value theorem. I like that they didn't say mean value theorem. Well, I mean, mean value theorem for intervals is a little more than that. It's like that f of c thing. It's like f of c equals to the average value. Like some value c outputs that average value. Then you'll have some special rectangle with that special height, which is that average value, and then that entire subinterval, or that entire closed interval times that width, the distance between those endpoints, times that special height that's the average value, gives you the same area under the curve. So I mean, maybe a question involving that would be pretty nice. I mean, how is mean value theorem for intervals different than average value of a function? Just a little, it's in addition to that. Okay. Nice. U sub. A lot of integration techniques you need to know here. Again, not something super duper complicated here. Like for example, this is just the integral of cotangent of x. Not super duper complicated stuff though. It's not like crazy exam integrals, Okay. These are also pretty good as well. But kind of definition stuff as well. But these are good. It's just a lot of techniques of integration here. This type of question, pretty good as well. Yeah, because f prime of x equals g of x, g prime of x equals f of x. The integral of f of x. Okay, yeah. Yeah, this is it. So, honestly, if I had to rate this out of 10, I'd probably rate it, in terms of difficulty, like a 3 or 4 out of 10. Nothing too crazy, right? Nothing too crazy. I think that a lot of it's foundational knowledge. There were some repeats to the questions in a way. I mean, if you want a bare bones calculus exam, this is like, okay, it's like it's nothing crazy. It's like, I think all students would be fine with this. A Calc 1 student, college, taking their final exam for the semester, I think they'd be pretty happy with this in terms of like difficulty. Like, oh, it was a breeze. Again, I think that a lot of potential. I think if I asked GPT-3 this, it would do a lot worse of a job. Assuming that you were okay with, as a Calculus 1 instructor, okay with pushing out an exam like this, you could probably just ask GPT, like, create another version of this, create another version of this, create another version of this. So, just to sort of maintain the academic integrity, right? Like, okay, I have a student who's taking the exam late. I don't want them to hear facts about the exam from other students, right? Because that's unfair advantage, right? I can't control what my students say, but what I can do is I can control by giving them a different exam. And again, a lot of teachers don't really do that sometimes because it's too much work, and completely understand, especially before AI. Oh my God, I would, if I was a teacher, I'd just give them the same exam. But now with GPT, I could just say, like, give me another version of this exam with same difficulty but different problems. I'm not gonna go over this in detail. I just want to see what it does, and then I'm gonna ask it for harder problems. Now, hopefully, it gives at least the 140 questions. Okay, now you see this. It's actually categorizing. Really interesting here. Just watch it. Let's see its thought process. It's actually not thought for a second. Crafting Calculus 1 questions. Okay, now it's actually mapping out. It did not say this before. It's actually being specific on mapping out like sections, like 10 on limits, 20 on continuity, and L'Hopital's rule, 30 on derivatives, 30 on derivative applications, 20 on integration, 20 on, okay. Is their math even correct? 30, 60. I'm pretty sure, yeah, their math's correct. That's 150. I like now it's categorizing. It did not do that. I think, yeah, on this exam, it did not categorize like that. That's pretty interesting. Um, but as you see here, it's still going. Okay, now it's saying now we're at applications of derivatives. I can already see, like, I can kind of read this here. Same type of question as before. And again, I did not ask you to make a difficult exam. I'm just saying I just asked you to create an alternate version, because again, I'm trying to prove here that AI can do a lot of the work for you. Now, one thing that's quite nice, again, if you have a pre-existing exam, you could probably just put the problems in it, and say just make problems like it. For a student who's taking it late. The one consequence to that is, again, make sure your institution has, again, like I've heard of institutions that have like an enterprise version of ChatGPT that where the data you can like actually put confidential data into it and it will not be exposed. Like your data is safe. Like it's like some contract you sign with OpenAI or something like that. Like OpenAI guarantees that your data will not be leaked or stored in the system or learned off of. You get what I mean. Like I'm pretty sure enterprise plans like that exist. So again, if you just have a general, like you pay $20 a month for GPT Pro, I'd caution. I would not go straight to putting your exam into it without some guidance from at least other people in your department or I would strongly advise that you do this in a more controlled ChatGPT environment, an enterprise version of ChatGPT, and OpenAI does offer that. So I'd recommend, doing that type of stuff, putting your already existing exam into it and asking it to create problems similar to that. That's fine. Just I would advise against that with the version of ChatGPT I'm using. That's like I pay for ChatGPT Pro. Like the consumer sort of, like I'm not an enterprise plan. So yeah. Anyway, let's see how this alternate exam does. So it's saying, oops, what is this? It's that extra page thing. I don't know why it does that. So okay, now it's saying version B. Okay. Whether you want to include that or not, or kind of trick the student, like, oh, is this the same exam that the other students got? I don't know. Want to troll them? Sure. Or just put version B. Doesn't matter. Okay. Similar problem. I would say like we can compare the two. If I download this, we can kind of compare the two side by side. Here, this is the original. Oops. And then this is the new one. So if we zoom out here, this is version B, direct substitution problem, special trig limit. Okay, wait, that's interesting. It said that it put sections. You guys remember that? I thought we had where is it? Here. I thought we had we saw that it put like section here. Like this section is on integration. Like yeah, integration here. Questions 11 to 111 through 130. It doesn't show that anywhere, and I'm pretty sure, right? Like it didn't do the same thing. Like it probably did the same thing here, but it didn't actually show up. Now this could just be due to my LaTeX IDE, or maybe it's just not registering in general. Just kind of weird, right? Like I'd expect it to like it. It's kind of weird at first that it did the categorizing for the alternate version. Um, I mean, yeah. I would say, like, looking at this, like, we looked at this exam. I just scrolled through this, I can kind of get the general gist. It did not ask a question like this with the piecewise. Um, Maybe I'd omit that because it didn't ask a piecewise question at all here. Piecewise function questions should often be asked, I think, with limits. Kind of tests your, like, knowledge or understanding, like, what does it mean for a function to be continuous at a point, differentiable at a point. So I would recommend removing this piecewise function here, or including it in this one. And I'm just kind of glancing at this. Intermediate value theorem, I remember asking a question there. I mean, I think this, like, looking at this as it is definitely, I think, a little harder. I mean, it's kind of the same thing, you know. Now it's asking, like, a foundational question. Like, these two are, I'm pretty sure, copies from the other exam here. Chain rule, critical point. Yeah, you know, I mean, again, there are some repeat questions. I mean, fair enough, because if this one right here is full of foundational questions, this one better be full of foundational questions as well. Let's see the integral stuff. Did it give 140? I remember something like this. Yeah, the odd, even. Gave only 128 questions. That's a little concerning. Again, when you make these exams, keep in mind, don't just print out whatever ChatGPT gives you. I'd recommend skimming through it, at least, and seeing if the problems are fair, if the problems are similar, and also if they're the same, if there is the same amount of problems, right? Like, this one had 140, didn't even have 150. This one had only 128. Again, just make sure that, you know, you're clear, like, same number of problems. Don't blindly just compile the LaTeX code, print it out, and give it to the student. Like, it's like, I mean, maybe the harder problems make up for the length. Like, I don't know. I didn't look at all of these problems. That piecewise one, definitely. People always have trouble with the piecewise, and the fact that it wasn't there on this, kind of a little concerning. But I do think that, again, pretty decent job. It did some repeat questions, as it should, especially because of how generalized some of these questions were. Like, for example, there was stuff with, like what does f prime of if f prime of x equals 0, what does that say, or something like that. Like, those are foundational. If you want that type of question on your exam, it better be on the alternate exam as well, because, you know, they should be tested on it as well. But the piecewise, again, I think that should be on the main exam too. So anyway, not too shabby. Again, a little weird with I think this has to do with the token limit, 128 versus 140. But I think overall it's not bad. It's really not bad. It's really okay. It's not bad. Let's go on to asking it this question now. Okay, make it 150 very difficult calculus 1 questions. Focus less on foundational questions, like, I don't know, let me mock it a little bit. Like, if f prime of x is greater than 0, what does that say about f? Like, I mean, I don't know. It was kind of mocking it, but that's kind of what those questions were anyway. I mean, let's see its reasoning here. Crafting advanced problems, tricky multiple choice, tricky integrals, series expansions. Okay. Series expansions, if they're talking about, like, Taylor series and Maclaurin series and stuff like that, that's covered in Calc 2, pretty sure. parametric derivatives. It keeps saying grouping, but it doesn't actually show in the latex. Like, for example, epsilon delta. Oh my god, they're gonna put some real analysis stuff in here? Dang. Okay. It's already looking a little interesting here. Advanced derivatives. Again, they don't show these they don't categorize it in latex. It's not like this is not showing. Let's see here. I'm very compelled by the epsilon delta though, because that's I mean you'll probably the epsilon delta definition of the derivative is something you should look at. I think people do look at that in Calculus 1, but actually doing epsilon delta proofs with limits is like a real analysis, like heavy sort of thing. If you don't know what real analysis is, it's like it's a college class that's way beyond this. Newton's method, okay, that's good. Newton's method, not taught that often in Calc 1, actually. I think even AP Calculus isn't even talk about Newton's method. That's also important. I like that. It's very diverse. Again, I feel like it has to stay on topic with Calculus 1 though, because it's a Calculus 1 class. So I wouldn't anticipate putting this on a Calc 1 test unless you've specifically done epsilon delta proofs and you've specifically gone over Newton's method. So yeah, I'm gonna look at like one of each sort of question. Like, I'm not gonna go into detail with this because I understand that's probably gonna be off topic at times. Like I already see series expansions here. Like that's not 100% in Calc 1. Although if it's talking about something with the Riemann sums and where you actually use the right-hand sum definition or the limit definition of the integral and you have to sort of use your series formulas, I get that, but series, that's not really what series expansion implies. I think it implies more of like Taylor series, Maclaurin series, stuff like that. You already see here 130, 131, 132. I already have a good feeling about this. Oh yeah, also like some convergence and divergence stuff. Not really covered in Calc 1. Miscellaneous. Again, it doesn't categorize. Kind of frustrating, but it is what it is. It's actually, I think, giving us 150 questions here, which is kind of shocking, especially since they're more complicated, right? It has to impact the token limit somehow. Let's see here. Calculus 1, final exam, advanced version. Okay, it's like the students I hate, I will give them this advanced version. For the normal students, I'll give them that first version. And the people that take it like can take the version B. Okay, this limit here. Okay, you can like see does L'Hopital's rule apply? Again, let me download this. It's nice. I'm really happy it gave 150 questions here. Let me just see if it did. Yeah, it gave 150 questions. That's awesome. Did not do that before. Some nice limits here. These are some good problems. Look at these limits. Wow, this is a good limit right here. It's a good limit. Okay, yeah, not something you'd really see in your Calc 1 class. Okay. Some good stuff here. This is definitely. Let me. Why is my camera keep going away? Sorry guys. I really want my face to be here. Yeah. These are definitely much more challenging limits. I can already tell just from the style, and it's more advanced limits. Limits that are more advanced than that. Okay. Oh my god, this is awesome. Incredible. Incredible stuff here. Look at this. Oh, this is not Calc 1. This is not Calc 1. Okay, this is awesome. Oh my god. epsilon delta definitions. Okay, go over epsilon delta a little bit. The definition of, the limit definition. I mean, this may be actually. Great epsilon's greater than zero. Some delta. Yeah, this may throw people off. I mean, uniformly continuous. Yeah, no, this stuff is not necessarily a typical Calc 1. I mean, yeah, 1-to-1, that's algebra thing. I mean, it's not like a proof sort of thing. Like, it's not that bad, the epsilon delta stuff. I expected it to be a lot worse. I would say, though, still really kind of outside the typical Calc 1 sort of style of problems. Intermediate value theorem, great. Advanced chain rule, yeah, definitely. This is a good chain rule problem. This is a great chain rule problem because you have to remember that sine cubed of 4x squared plus 1 is just sine of 4x squared plus 1 cubed. You really want to pay attention to that there. It's like chain rule twice in a way. These are good problems. Very nice problems. I really like these problems. These chain rule ones. These chain rule ones are great. Yeah, these chain rule ones are awesome. Really good. I really like these problems. Like these are actually doable by a Calc 1 student, knowing their knowledge, using their knowledge of derivative rules. But this is actually this is nice though. It's like you really test your understanding. These are the types of problems I'd be proud to put on my test in terms of complexity. These are nice. Especially this, like sine of x, a sine of x. Like, oh my god, chain rule multiple times. It's awesome. Look at this. So what is this? Exp. F of x equals to the exponent. Let me see this problem. It's so interesting. X squared I think you could just use okay. That's good. Yeah, it's like the exponent of this. Okay. Kind of throws people off at first, but that's a good problem. Implicit differentiation here. If someone knew partial derivatives, they'd just be killing it right now. Like, oh my god, negative partial derivative of f with respect to x over partial derivative of f with respect to y. Like, they'll just be killing it right now if you know partial derivatives. But it's awesome. This implicit differentiation is very important. This is the skill of being able to do implicit differentiation is very important, especially when you're dealing with relations that are not necessarily y as a function of x. Nice problems. They should have added stuff like this to the last exam. This is like really good, important to know. Really nice. Parametrics. Awesome. I would say even don't even give them this. This is something that you should know just because of your knowledge of the chain rule. That dy dx equals to dx dt, dy dt over dx dt, because dy dt is just the same as dy dx times dx dt, right? So using your knowledge of the chain rule, you could just figure this out, or just the change in y over the change in x is the same as the change of the vertical movement over the change of the horizontal movement. So, I mean, I don't think this is really given, right? You should know it if you know parametrics. awesome parametric second derivative. Again, you should know parametric second derivative, but it's nice that they're giving you this. So, really good problems. They should give these types. These are great problems. But I'll be completely honest. I think that they should add some like word type problems, like with position, velocity, acceleration type stuff. I think it's important to sort of include that into the parametric, because like context and you get what I mean, right? Like these are really mostly just applying your rules and they're nice. I love these types of problems. They're great. But in terms of like parametrics itself and its significance and how this relates to like a real world problem and relative to like particle motion and stuff like that, I think that's very important to include problems using particle motion. But again, not bad. Again, stuff like this, it's they're nice. I love these types of problems. I love the using the rules and computing these like fancy limits, derivative, evaluating limits, these derivatives, these integrals. I love it. But the practicality. I mean, yes, a lot of these are pretty complicated problems, but also the practicality. You should be talking a little bit about the applicability of these concepts, like using. Personally, I hate word problems. I hate them. I hate application problems with a passion. But sometimes you have to think about the practicality of things. Like I'm a pure math guy. I love just math by itself. The applications are kind of irrelevant for me. But I think sometimes, again, there's some exceptions. Like, for example, even with position, velocity, and acceleration, knowing that you take the integral of the velocity and, how it relates to the position and stuff like that, the displacement, it really helps you better understand FTC in that way. So again, there are really good pros to better, of how applications can help you better understand the math. But also the practicality. A lot of people take calculus not to just be math majors. In fact, a lot of math majors maybe earn the AP credit through their high school. I don't know. But a lot of these people who are in calculus are probably not going to become math majors. They're probably going to go into engineering or something in the STEM field. So you have to really look at the practicality of these problems. Like, are these problems really preparing them? Like, yes, the skill of finding the second derivative of the parametric second derivative is very important, but include that in a larger scale problem. Like, I understand that these are multiple choice, and these are good multiple choice. They are nice. I love these problems a lot, but we have to think about the practicality here. And of course, in difficulty, like the epsilon delta stuff, I would not necessarily include that. But I'd put more applications into this. Like the last one included related rates, but not really. Like, especially, I was laughing at that ladder one because it just included some information about a ladder, but then just sort of ignored it and just said x squared plus y squared equals l squared. Implicitly differentiate this. Like it didn't bring back sure the ladder equals L, but like it didn't really, it wasn't really intuitive. At least that brought up related rates. But again, I think we should connect this to the larger scale of things, especially like parametrics and particle motion. Okay, now we have optimization. This is nice. Actually, I'm gonna take back some of the stuff I said, especially if they have related rates here. I don't 100% know if they have related rates here, but this optimization is awesome that they're including this. This is again practicality. I should have probably looked at this before I made that whole talk about practicality. This is pretty good. Optimization is super important. It's super applicable in the real world. Really nice that they included this. This not necessarily an important type of optimization problem, like inscribed under the parabola. That's like more math heavy. But then stuff like a square box, and the cost is minimized. Stuff like that is very nice. It's very intuitive. It's very important, in terms of real world applicability. I think, again, it's multiple choice, so it's kind of like straight. This is kind of a straightforward answer. You can't really do the entire problem. Um, I mean, yeah, they're not too bad. They're not too bad in the optimization. I like the box one. Uh, yeah, it's good that they're putting optimization. I love optimization. They're great problems. Um, Honestly, not bad. I put this on a test. They're really nice. Um, Newton's method, very important. Um, okay, gives you Newton's method here. Um, so talks about like one risk is, okay, kind of like your understanding of Newton's method. Um, this is again more of like the computation. Like it literally just gave you Newton's method right here. Like you take some approximation and then you do f minus f of that approximation over the derivative of that approximation, the f prime of that approximation, and that'll give you another root. Newton's method is, okay, it's like oscillate about a root. Again, this is all great. These are good problems. Again, I would recommend, like, again, Newton's method's not covered a lot, especially in the typical Calc 1 class. Maybe there's a mention of it in maybe the textbook or something, but not necessarily that at least from my knowledge, big Calc 1 topic, Newton's method. But it is a really nice way to see how derivatives are important. Like, it's such a natural question, right? It's like people often, they first learn derivatives and they're like, well, okay, we can find the slope of the tangent line at a particular point. Well, what does it actually tell us? What it tells us is when something is maximum, it can help us find maximums and minimums without using the calculator. Right, well, how do you think the calculator actually finds it? Well, they use the secant lines. They find infinitely many secant lines. They put them into tangent lines. That's how the calculator does that. And you see here, like, this is possible with derivatives. That slope of the tangent line actually tells us when something is a function is increasing or a function is decreasing. Well, guess what? The point where it's not increasing or decreasing is extrema. And it's such a natural question. Well, derivatives can give us extrema. What else can it give us? Well, it can actually now give us zeros, because it's fundamentally, it is such an important question for mathematicians. Like, how can we find zeros of functions? Because there are we have, like, for example, degree 2, we have the quadratic formula, right? The Babylonians discovered that, using the completing the square method. Cubic equations. There's this huge cubic formula. Oh my God! Don't even get me started on this. It's huge sort of discussion and debate over, and how they got that. And now with like quintic equations and all that stuff, like usually you need a calculator. You now need a calculator for that stuff. But then there was stuff like Descartes' rule of signs, rational roots test, and it's like, what if there's another way? Using calculus, just like how we use calculus to find extrema, how can we use calculus to find zeros? It's such a big question in math. Like, it's still kind of unsolved. Are there better ways to find zeros? Of course, not using a calculator, just by pure, just by calculus or whatnot, or other techniques, right? Like recently, for example, if you look at like factoring quadratics, one of my favorite like math people that I follow, Professor Potion Low, he recently talked about this new way of factoring quadratics, because quadratics, often when you factor quadratics, you have to guess and check and all that kind of stuff. Kind of unpredictable, but then he found this way, and again, I don't necessarily think it was his originally, but he's kind of polished it up. It's just like a straightforward way to factor a quadratic, like straightforward way. Like, you don't need to guess or check or anything like that. And of course, the real straightforward way to solve a quadratic is quadratic formula. But again, by the Babylonians, using completing the square. If you want to see the proof for that, just look at my Understanding Not Memorizing series. I did it, and it was like the 4th video or something. But yeah, such a natural question to ask, and that's why Newton's method. It's Newton-Raphson method. Joseph Raphson also. Like there's debate. Like people say Raphson did it earlier. Let's not get into that discussion now. Very interesting. Newton had a really good publicist, so that's why we hear Newton so much. That's why they say Newton invented calculus. No, we also had a guy named Gottfried Leibniz. He was also in it too. So yeah, again, Newton's method. I think it's very, very nice, application to derivatives, especially also the intermediate value theorem, how zeros exist. I recently read an article on this recently, how intermediate value theorem actually connects to Newton's method. Pretty nice. But yeah, again, not typically covered in your Calc 1 class. But it's nice. If I taught Calc 1, I would definitely talk about Newton's method. Again, now mean value theorem and related. I'm guessing it's alluding to related rates. It's giving us mean value theorem here. Okay, it's giving us conditions. Again, kind of foundational question. Well, I mean, again, it's kind of doing what I asked at the same time. It's applying mean value theorem here, in a way. But, okay, this is another mean value theorem. Not really, Cauchy's mean value theorem, it's not covered in Calc 1 necessarily. I mean, again, I would probably talk about this in my Calc 1 class, my theoretical Calc 1 class if I taught it, 100%. More mean value theorem, increasing function theorem. Okay, I mean, again, people probably are not directly aware of it, but you could probably, eliminate, do it by elimination, maybe. Yeah, that's a good question, foundational question. This is f negative 2 equals 6. Yeah, okay, alright, extended consequence. This is awesome. I love these problems. So much better than that lame exam. I'm going to call that other exam lame. This is just awesome. Oh my god. Incredible. Okay. L'Hopital. It also didn't talk about related. Well, I mean, I think and related. Like I'm guessing relative to the mean value theorem. But I don't think it talked about related rates. Optimization though is pretty good on this. Maybe they'll talk about it later. Okay, this is L'Hopital's rule. Which is complicated. Which is complicated. Which is correct. One of the answers is no, it equals to this limit, which is complicated. What? This is awesome! Oh my god, this is so human. This is such a human test. This I think a human would write this. Which is complicated. That is really, really impressive that it can imitate these sort of trick, or I don't even know, maybe that's the right answer. I didn't even read the question. But just reading that, it's like so human. It's like, which is complicated. Like GPT could probably do this, but it's like, which is complicated. It didn't just abruptly stop. It was like, it's just being human. It's like, oh, this is too complicated. I don't want to deal with it. It's like, it uses human behavior. Like, oh my god. Also, series expansions, I'm assuming it's using Maclaurin series to sort of approximate this. Well, Maclaurin series for what? Natural log doesn't even exist. It's only 1 plus x. I don't know. I'd have to look into this problem more. But I love this, which is complicated. It's awesome. Oh my god. Okay. this is some L'Hopital stuff. I hope I'd anticipate that there is, like, again, I was talking about that trick L'Hopital's rule question where it's like you think you perceive it as an indeterminate form, but it actually isn't an indeterminate form, and you did it incorrectly and get a trick, and one of the answers is a trick. I anticipate that this actually contains that type of problem. You never know. I don't, again, I don't, we've already been at this for like over an hour. I don't want to dive too deep into that, but that's pretty. I'm really proud of this version of the exam, especially those first few limits. I was like already like, wow, that's completely different than that first direct substitution limit. Oh my god, of the polynomial. Okay, this is nice. A right hand limit of this. I love this. This is awesome. Oh my god, GPT. I still can't get over this though, which is complicated. It just doesn't want to continue. Instead, it's just like, which is complicated. That is very human. Honestly, if someone gave me this exam, I really wouldn't think that ChatGPT wrote this. I wouldn't know. I really wouldn't know if ChatGPT wrote this or not. It's incredible. Okay, L'Hopital's. See, okay, this stuff, not in Calc 1. This is all, this is Calc 2 stuff. It should, I think a Calc 1 student, like, I think Calc 1 should cover this. You are able to understand this, even before learning it's integrals. You could probably understand these expansions because they use derivatives, especially like the general expression for the Taylor series. It just uses derivatives. Again, but then, all right, yeah. This is all Calc 2. Again, like x to the n over n factorial. But wait, you gotta plug in the x. You gotta count for the x squared, right? Trick question. I like this. This is pretty good though. I think that this is, again, Calc 2. They cover this at the end of Calculus 2. So wouldn't really want to put this at the end of a Calc 1 exam. Okay, well, now we're at integrals. Finally. Well, I think there was like one of the parametrics had an integral thing in it. Some definite integrals, great. There are some good integrals. Some good. Well, yeah, they're pretty good. Parts. Expecting maybe a little more advanced, like some crazy integrals, but I mean, pretty good stuff. Use substitutions or partial fractions. Though carefully. What does this mean? Though carefully? You don't think the student is always careful when solving their problems on their tests? You think that like they're reckless, they just guess and they don't know? Why this problem specifically? All problems are worth the same. Probably, that's usually how it is with multiple choice. But for this one, though carefully. You didn't tell me that when I was doing the chain rule. I could have made a mistake there. Though carefully, okay, I'll do partial fraction decomp, you said carefully, as you say. I totally wasn't careful with my other problems. Okay. The result is commonly, okay, well, commonly, it's probably like simplified form. Okay. More integration by parts. Okay. Or known formula. Okay. Good. These are good problems. It's like, it's also error analysis in a way. Like, is the work correct, or miscellaneous advanced topics, more limits, derivatives. These are good problems. Foundational, good. I like that they threw in like one foundation. It was pretty good. Implicit differentiation. Carefully. Okay. That's a good problem. It's a little not typical. It's good. I'm giving you this derivative. By the way, this function, by the way, x to the x, the critical value for this, I'm pretty sure it's like e or something. I'm not 100% sure. It's like really interesting how like your critical value is like x equals e. I think that the critical value for that is x equals e. It's crazy. Or like one. So not x equals e. X equals 1 over e is the critical value. I remember I did a problem where it's like, find the critical values of x to the x is like part of an experiment. And it was like 1 over e, and it was just like so cool, right? Like how could e get involved with x to the x? It's like they seem completely unrelated. It's awesome. This is okay. Expansions. These are good problems. I keep saying it. That I'm so proud of ChatGPT with these problems. These are really good. I really shed a tear. This is awesome. They really did a great job with these problems. I'm really proud of ChatGPT right here. I'm gonna say good job. Make sure to not include series expansions next time. It's covered in the end of Calc 2. Goodbye. Thanks. Let's see. Is it thinking? No details available. This is like, thanks for your feedback. I'll remember to exclude series expansions in the next version. Have a great day. Awesome. Oh my god. ChatGPT, man, you really did a good job here. I'm really impressed with this version. All the other ones are pathetic compared to this. This is some like good stuff. Some good stuff. Really good. Anyway, yeah, this is a very long video, but hopefully you get the gist of the power of AI and how it just creates, it's able to create like this 150 problems, and this time it actually did put 150 like this, full of complexity and human thought, like literally which is complicated, and do it carefully. It's like so human, right? It's like a teacher would say that, right? Like it's, you know, it's so nice.